All right, we're going to do another equilibrium problem using the ICE method for solving this. So first, let's go ahead and write out our reaction for this. And we already know K. And we know that K will equal the products raised to the power of their coefficients over the reactants. All right, in this case we have some initial concentration, so let's go ahead and write out those. I'm going to put a subscript 0, which means at the start of the reaction, so that means the initial time. So we have a 1 molar solution of hydrogen. A 2 molar solution of fluorine. And we're starting with none of the hydrogen fluoride compound yet. So this one hasn't been formed yet. So we only have initial concentrations of the first two. And that's actually helpful because in this case, we're not going to have to solve for Q like we did in the first example. Because remember, anytime you have 0 for any of your concentrations, the reaction will shift towards the 0. So we already know that the reaction is going to shift to the right. So we can go ahead and set up our icebox. I stands for initial, so this is going to be our initial concentration. C stands for change, so it's going to change by some amount as the reaction shifts. And then E stands for equilibrium, so once it's reached equilibrium, we can calculate our new concentrations. So we have initial concentrations of these two. And we know it's going to shift towards the 0. So we know we're going to increase the amount of hydrogen fluoride and we're going to decrease the amount of the two reactants. We don't know how much yet, so we're going to put X for these amounts. And remember that the X's need to be in proportion to the coefficients in the reaction. So we're going to put a 2X here because of that 2 right there. So now we can say that at equilibrium, we have 1 molar minus X here, 2 minus X here, and 2X for the hydrogen fluoride. Now we can take those amounts and plug them back into K. So this was given to us in the question. And at equilibrium, we're going to have 2X for hydrogen fluoride. Don't forget to keep that square on there. So it looks like this. And now we need to solve for X. So now it has become quite a challenging algebra problem. Let's go ahead and start by simplifying it a little bit. Don't forget that when you square something like this, you have to square both the number and the exponent. So now we can say K is equal to 4X squared. Like this. And what we're going to need to do is to combine our parentheses on the bottom of that fraction. So hopefully you remember from algebra there's a FOIL method, first, outer, inner, last. You need to go ahead and combine those and move them to the other side. And once you have done the math for this, you're going to end up with a quadratic equation. And the reason that you're going to have a quadratic equation is because you're going to have an x squared, you're going to have some amount of x, and then you're going to have a number, and you need to have all of that on one side of the equal sign, and then for a quadratic to work, you need to have 0 on the other. So take a few minutes and pause the video and see if you can do the math to get this in the form of a quadratic equation. And I'll go through the math for this during the live session if you have trouble with it, but I want you to try it yourself first. And if you do it correctly, you should end up with this quadratic formula. So you have, notice, x squared, you've got your x, you've got your number without the x, and all of it equals to 0. And so now you can do the quadratic formula. So here's the quadratic formula. We have a, b, and c, and you're going to solve it twice. So you're going to plug in your numbers and use the positive sign one time right here and the negative the other. And so what you're going to end up with is two different values for x. Once you get your two different values, only one of them is going to make sense. So if we go back up to our icebox up here, notice that if x was 2.14, if you plug in x right here, 1 minus 2.14 is going to give you a negative concentration, and that's impossible. The lowest concentration we can have is 0. So that will tell you which one is going to be the x value. So again, only one of your x's will make sense. The other one will give you a number that's going to be impossible. So now we know what x is, and so finally we can plug everything back into the equilibrium amounts. So we can go back up here and say that at equilibrium, the concentration of H2 is equal to 1 minus 0.968. And we'll do that for each of them at equilibrium. And those are our final answers. And that's it for example number 2. I'll do one more video with example number 3.